Well, hello C++ programmers and fellow game developers. This video is a description of one approach toward incorporating artificial intelligence into some of your NPCs, or your player into some of the sprites in your game. So how do we do this? Well, I have a little example that I'd like to track through this video, and this example has really three different kinds of sprites. A circular yellow sprite, a yellow star sprite, and then a multi-frame sprite, a spinning star. See the spinning star there? Now the spinning star is the bad guy, or the player maybe, I don't know, but he has no AI. He or she just bounces around the screen, and if that spin star collides with any of these other stars, these single frame sprites, the circle or the yellow star, if the spinning star collides with those, then it explodes, first of all, and then it comes back in the same position where it exploded. It comes back as a smart sprite. Now, how can you tell a smart sprite from a dumb sprite? The smart sprites have either a 0 or a 1 in the middle. So I'm putting a 0 or a 1 so we can tell their state. And the dumb sprites don't have a 0 or a 1 because they don't have any AI. 0 means normal. So the states, what are the states of these smart sprites? They have two states. One is normal, where they just bounce around like dumb sprites. And the other state is evade. So they're trying to evade the spin star. And you can see them switch. So they're at 0, and then you can see them switch to a 1 briefly. See, that one just went to a 1. And 1 means they go in the directly opposite direction of the spinning star. Okay, so that's the idea. So we have sprites that start off dumb. They collide with the spinning star. They come back smart, and they have two states. Okay, so the two issues involved here are, how do we incorporate intelligence into the OO framework and into the NPCs? And the second question is, how do we choreograph the communication that has to occur, in this case between the player and all the other stars that it's trying to explode, so they can react appropriately. And in this case, react appropriately means that they want to evade him. I mean, they could try to shoot him or do something else, but I'm trying to keep this very simple. So the answer to this first one is we use state-based AI, and it's pretty simple. And the answer to the second one is that we use the observer pattern. Okay, so let's take these one at a time. First, let's talk about state-based AI. Okay, so to that effect, what I have here is there's the subject sprite, and here's the player sprite. We don't want to look at the subject sprite yet because that's more about the observer pattern. Let's look at the smart sprite. So what's the difference between a sprite and a smart sprite? A smart sprite has this notion of state, namely that it's in a state of either normal or evade. Normal means it's just bouncing around the same way it did when it was a dumb sprite. Evade means it determines where the spinning star is. And for example, if the spinning star is to the right of me, I want to go left. If the spinning star is above me, I want to go down. In other words, I want to evade the dude. So how do you evade this guy? You evade this spinning star by going in the direction away from where the spinning star is. So that's what we'll have to do. And notice we have this notion of a safe distance, which, by the way, I can control. Let me just see. I think I can make that safe distance. Let me see. How do I make it go up? I think I hit plus. Yeah, let's make it go down. So the safe distance is very small now, and they're all going to get. They'll probably, because let them get closer, you know. So let's see. This only refers to the smart ones. I don't know if that's working, but you can see the safe distance is now 58. And so they'll let the spinning star get real close before they start to evade. Let's see if the spinning star gets them quicker. Ooh, yeah, I don't know. Is he getting them quicker? See them switching, though? I think I like it better at this one. Anyway, you get the idea. So let's come back here. Okay, so a smart sprite has two modes, normal mode and evade mode. And that's about it. Really, all that a smart sprite does is then check for all that. So let's look down here at the update function. It's just now notice there are some functions that I put in here to tell the sprite to either go left, right, up, or down. And those directions will be dictated by where the spinning star is. If the spinning star is to the right of me, I want to go left, so I'll do this one. So let's see if that makes sense of how we do that. Okay, so really everything happens in the update. Of course, in the constructor, we start off with a smart sprite being in the normal state. Okay, so let's go down to update, and we'll just see how state-based AI works. Okay, so first of all, let me point out to you that a smart sprite is just like any other sprite except for the update. So really, I don't even know why I have I have a draw. I mean, I'm really using the draw and the update in Sprite. I actually extend them. So it's kind of interesting the way I do that. Let me show you the draw. In the draw, here I am. This is how you use a function in a base class. So smart sprite is derived from Sprite. And I first want to draw it just the same way I drew it a normal sprite. But now what I want to do is I want to draw this state that it's in. So what I do is I offset it by 10 down and 10 over. I get its current position, then I offset by 10 over and 10 down. That's so either a 0 or a 1 will appear in the middle of this smart sprite. And then I get its current mode, put it in the stream, and then I just draw it right on top of really on the screen. I'm using the I/O manager to draw it on the screen at this position that I just computed. So notice I'm actually reusing the functionality in Sprite. Here I'm using the draw function, and here I'm using the update function. So in what way am I reusing? Well, first, I just tell the sprite to go draw itself, and then I draw a 0 or a 1. Here I tell it to update itself, and then based on where it is now, having updated itself, I may have to change modes. So what I do is I know my position. Here's my XY position. Here's the XY position of the player. And how do I know that? The player told me because I've used the observer pattern, and we'll get to that in a moment. So let's assume the player tells me where the player is. And I already am saving its width and height, so I get the player's position, find the middle. I'm basically finding the middle with these things right here. And then I just use the Euclidean distance formula to find the distance between me and the enemy. And there's the distance formula. It's probably right here. You subtract the two x's, subtract the two y's, and square them and find the square root. Except that I'm using this math function to find the hypotenuse. Okay, so Euclidean distance, nothing hard. So I find the distance to my enemy. Then I check what mode am I in. If I'm currently in normal mode, if my distance to the enemy is less than whatever that safe distance was, I got to say, whoa, I'm out of here. I got to get out of here. So I set to evade. If I'm in evade and I'm far enough away from the spinning star, then I switch to normal mode. And you kind of saw that. Otherwise, what's this otherwise? Otherwise, I'm in trouble and I got to evade. So if I'm in evade and I can't change to normal, then I got to keep evading. So I check. Is my current X to the left? Is it to the left of the enemy sprite, the spinning sprite? If I'm to the left, I want to go further left and get far away from this dude. If I am to the right, that's what this is saying. If my X coordinate is bigger than this guy's, so if this guy's at 25, I'm at 50, well, that means I want to go right. So I just want to make sure my direction is away from the bad guy. Okay, so that's in a nutshell how I make a smart sprite, how I give a sprite some intelligence. I simply use a state-based approach, and I use the Euclidean distance formula to see if I need to evade. Okay, that's that part. How do we do the communication? Well, the communication happens really through the observer pattern. So what I have here is, let me show you the subject sprite. The subject sprite is a multi-sprite. Remember, it was a spinning star. Let me just recall that it's a spinning star. So this one's the subject. By subject, he's the player or whatever, the one that's killing everybody. And it's a multi-frame sprite. That's not a problem though. So I just derived my subject sprite. It's a multi-sprite, except that I kill people for one thing, and also I want to tell all the other sprites where I am so they can evade. Okay, so where am I? I've got the constructors and I have attach and detach. Now, if you don't remember how the observer pattern works, you might want to go back to a previous video that I did where I described the observer pattern. So the attach and detach, both of these are really important. Attach is easy. I just push the guy, the NPC onto my list of observers. Detach is a little more complicated, so that code is down here and I'll show it to you. Okay, so attach is a one-liner. I put it in the header. So what is different about the subject and the observer? What's different about a subject sprite and a normal multi-sprite? Well, the subject sprite has a list of observers, number one. And number two, it has additional functionality. It has an attach and a detach. Now, when does a sprite get detached? Well, this smart sprite. I'm sorry. I detach an observer when the observer explodes. Okay, so if that observer, and I don't think they ever actually leave, but we could explode them if they explode a second time, just detach them and never bring them back or something, whatever. Okay, so we have attach and detach, plus we have additional functionality in the update function whereby I tell the observers where I am. So that's it. Okay, so let's look below at these things. So here's the detach. Here is how you remove an item from a vector. Is this a vector? It's a list. Here's how a vector or a list, it's the same. Okay, I want to detach this guy. This is an observer. I'm going to remove this observer. So I use an iterator, and the iterator, I start the iterator at the beginning of the observers list. And while I'm not, I ought to also, while I'm not at the end, if the one I'm looking at is the observer I want to remove, then I erase the observer. Now, here's the trick. When you remove an item from a list, this iterator is invalidated. But that's okay because the erase function returns an iterator that points to the next item in the list, although it doesn't matter because I'm leaving anyway. So I return because I'm done. I just removed this guy from the list, so I return. Now, remember, this is a Smart Sprite star, so I'm just getting it out of the list. It's a list of Smart Sprite stars, so I just take it out of the list. I didn't delete it. I'm not sure why. I should probably check this for memory leaks. But anyway, if this is not the one I want to delete, just update the pointer. Okay, and then update is fairly straightforward. How do I do an update? Once again, reuse. Notice how much reuse I'm getting from inheritance. That is, my subject sprite is derived from multi-sprite, and to update the position of the subject sprite, I just use the update in the base class, and then I just incorporate now this additional functionality into the derived class, namely, I tell all my observers. So I run through my list of observers. I tell all my observers where I am. So I get my position and I pass it over to the observers. So I tell each of the observers, here's where I am if you want to know. Now, this is kind of a brute force approach. What I could do is keep some kind of a data structure, an organized data structure, and only inform observers that I know or might be close instead of all of them. But I'm just keeping this simple. Okay, so that basically is it. We have the how do you incorporate AI? You use state-based approach, and how do you choreograph the communication? You use the observer pattern. And so I hope this helps with helping you to figure out how you can incorporate a smart sprite into your game or your animation. Happy programming. Brian Malloy, over and out.